All right, so this video is on single replacements and how to predict the products of single replacement products, okay, or single replacement reactions. So remember, single replacement reactions are where you have a compound and an element, and what's happening is the element is replacing the thing like it in the compound. So the product will be a different element and a different compound than it was to begin with. There's a rearrangement. There is one side note I need to make here. Zinc is always going to be +2 despite the fact that it's a transition metal. It actually has a set oxidation state. So anytime you see zinc now, you can assume it's +2. You won't see Roman numerals for this anymore. And silver is another one, Ag. It's always going to be +1. Even though it's a transition metal, it is a transition metal that has a set charge. So again, no need for Roman numerals for that. The reason I say these here is because they often pop up in single replacement reactions, okay? So some single replacement reactions are not going to occur because some elements are not going to be active or reactive enough to replace others. If you remember, I've already kind of hinted at this idea. There's a list on page 7 of your chemistry reference table called the activity series. I've mentioned this briefly before. What you really need to take away is a higher element that's more active on the activity series will replace lower elements. If it's lower, it won't replace, okay? So that's something to keep in mind. So taking a look at this one, my slide's all messed up. Taking a look at this next reaction, okay? Oh, no, it's not. This is the activity series. So everybody take a look. Here it is off of page 7. This is a screenshot of it. So I didn't realize that I did it that way. So we see lithium is the most active metal and gold down here is the least active metal. So lithium replaces everything, gold replaces nothing, okay? So it's all about higher replaces lower. Here are your recipes for single replacement. So we have where A is replacing B. Notice how B got kicked out. And so we end up with a compound between A and C. This is a metal replacing a metal. So notice that A replaced the first thing, which would be the metal. Then you have an active metal replacing hydrogen from water. So it's a metal with water. And so it forms that metal hydroxide and a hydrogen H2 diatomic molecule. All right. The next option you have is a metal reacting with an acid. HX is a generic way of representing an acid to form a metal with whatever else was in the acid other than the hydrogen and H2. And then last is what's called a halide-halide. Remember, halide is a fancy way of saying halogen. So bromine, chlorine, fluorine, and iodine, replacing one of those other guys. So I have either bromine, fluorine, iodine, or chlorine here, and they're replacing the thing like it out of the compound. Notice this time C got kicked out, not like here where B got kicked out. Okay, so when it gets kicked out, remember all of those are diatomic, so you will need to remember your diatomic 2 there. So let's start with the first one, metal replacing a metal. Remember, we're going to have to check that activity series when we do these. Okay, so we have potassium reacting with sodium chloride. So potassium is a metal, so it's going to replace the thing like it in the compound. So metal replaces the metal, so that would be sodium. So potassium replacing sodium. And what happens is our new reaction, we have to ask ourselves, can potassium replace sodium? Meaning, is potassium higher on the activity series than sodium? So we take a look at our activity series and we locate our potassium and our sodium. So we see potassium's up here and sodium's down here. So of course we realize that potassium is higher than sodium on the activity series. So the answer to the question is yes. So this reaction does occur. So we can proceed to determining our products. So our products would be potassium now with chlorine, swap and drop, +1, -1 and sodium over here by itself now. Okay, so don't forget to swap and drop, and it's going to go through that again. Last, we could balance. In this case, it's already balanced, so we don't have to do too much for that. So let's try another one. We have SN replacing iron, because again, iron's the metal. So we have to take a look at our activity series. So if you pull up your activity series in front of you off of page 7, you're actually this time going to find that 10 is actually lower than Fe. So this is not going to work. So the reaction is actually going to be very simple to write the products for because your answer is no reaction because 10 is not higher than iron. So you write just no reaction, does not occur. You don't even have to predict the products because it doesn't happen, okay? So this is kind of how these work. I do want to quickly forward to another one that is that B type where a metal is replacing water or replacing the hydrogen in water. I want to point out that you need to think of water as HOH. So the sodium is going to try to replace this first hydrogen. If sodium is higher than this hydrogen on the activity series, it occurs. Turns out in this case, it is. So because it's higher, this reaction does occur. So sodium is now going to be with OH and forming a sodium hydroxide molecule. Hydrogen is going to get kicked out by itself, but because it's hydrogen and it's a part of Brinkelhoff, it needs its 2 because it's diatomic. Okay, so this is our second type of single replacement reaction. All right, it's just showing you to swap and drop the sodium hydroxide and to balance it at the end. All right, so next, we have a metal replacing hydrogen from an acid. You're going to know this is different from the previous one because instead of H2O here, you're going to have an acid. And this could be anything like HCl or it could be H2SO4. But it's going to start with a hydrogen. It's going to be a metal. What's going to happen is that metal is going to get together with everything else in the acid that is not hydrogen and form its own compound and kick out the hydrogen in its diatomic form as H2. Again, you're checking the activity series. Single replacement activity series, these two go together. You have to check your activity series for the single replacement reactions every time. Okay, so here's an example. We have magnesium and hydrochloric acid, or at this point, you just know this is hydrogen monochloride, but you now know that's an acid because it starts with hydrogen. So magnesium is going to attempt to replace the hydrogen. So we need to figure out if magnesium is higher on the activity series. If we take a look at the activity series, magnesium is higher than the hydrogen, so the reaction does occur. So now we have to put magnesium with everything in the acid that's not hydrogen. So that's just the chlorine in this case. So if we do that and we put our magnesium and chlorine together and our hydrogen's kicked out, we've got to go through and swap and drop and figure out our actual reactions. So we know that this is going to have to swap and drop, and this is going to be diatomic. So H2 over there, now we got to swap and drop. So if we think about this one, magnesium's +2, chlorine is -1, so our actual formula is MgCl2. So we go back up there and we fix it, and now we've got to balance this reaction. And if we were to balance it, we've got 2 chlorines over here, so we'd end up needing a 2 right there. If we put that 2 right there, it's a balanced reaction. So the last type of single replacement reaction that you need to be familiar with is this halogen-halogen or halide-halide replacement. So again, this is the activity series that's above the metal. So if you're looking on page 7, there's like the activity series of metals, and right behind above it in teeny tiny little text is the halogen one. And this literally goes in the order of the periodic table. So if you're looking at the periodic table, you have fluorine, then you have chlorine, then you have bromine, and then you have iodine. So it goes down in that same exact order. So that's kind of nice because you don't even sometimes have to check this. You can just look at the periodic table. So this is limited exclusively to fluorine, chlorine, bromine, and iodine. Okay, and these 4 are replacing each other, and that's it. Those are the only 4 you got to worry about. Again, higher replaces lower. Fluorine replaces everybody. Iodine replaces nobody. So here's our first example. Fluorine is trying to replace the thing like it in HCl. So fluorine is trying to replace chlorine. So is fluorine higher than chlorine? And the answer to that is yes. So this reaction proceeds. So fluorine is going to kick chlorine out by itself. So we expect to see chlorine over here by itself. And now we expect to see a compound between hydrogen and fluorine. So if we take a look at that, that's going to look like this. There is some things to keep in mind. We do have to keep some things in mind here. This is going to be a diatomic, and we got to swap and drop. So we add our 2. We swap and drop, and we find out +1, -1, so there's no need for subscripts on HF. Now we've got to balance it. Once we add in our 2s, we now have a final product here. For single replacement, the big takeaway is you're always going to have an element reacting with a compound. Typically, that element is replacing the thing like it in the compound. For single replacement, you really need to use those activity series off of page 7 in order to even determine if the reaction occurs or not. And that's about it. So that's your synopsis of how to predict products for single replacement reactions.